We're looking at quadratic applications. So the essential question is, how do I use quadratics to solve problems? Your learning intention. I'm learning to use quadratics to solve problems. You've got two warm-up questions. Find your x and y intercepts for the two linear functions. Pause the video and see if you can do those on your own. Well, I do hope you tried. For your x-intercept, remember that's where y is equal to 0, so this term is gone. 6x is equal to 24. Divide both sides by 6, and x is equal to 4. So the x-intercept is at 0.40. Your y-intercept. The y-intercept is where x is equal to 0. So the term 6x will be gone. We're left with negative 3y is equal to 24. Divide both sides by negative 3. Y is equal to 24 divided by negative 3 is negative 8. This point is a point 0, comma, negative 8. If you were unsure and struggling, pause the video and do the second one on your own. Okay, so for your x-intercept, y is equal to 0, that term goes away. 15x is equal to 45. Divide both sides by 15. 45 divided by 15 is 3. So the point is 3, comma, 0. Okay, for your y-intercept. The x term is gone, so we have negative 5y is equal to 45. Divide both sides by negative 5. Y is equal to 45 divided by negative 5 is negative 9. This is a point 0, comma, negative 9. Hopefully you are no longer struggling with how to find the x and y intercepts. Now let's look at our quadratic function problems. An object is dropped from the top of a building. The building is 480 feet tall. The function that models this, your function evaluated with time, is equal to negative 16 time squared plus 480. It gives you the height of the object after t seconds of falling. How long will it take the object to hit the ground? So if you're looking for the height of the object on the ground, what is it? If it's on the ground, we know that f, the value of f of t will be 0. We're going to substitute 0 in and then solve. 0 is equal to negative 16t squared plus 480. First step. I'm going to subtract 480 from both sides. Negative 480 is equal to negative 16t squared. Divide it by negative 16 on both sides. Negative divided by a negative is a positive. I still need to know what is 480 divided by 16. And it is 30. 30 is equal to t squared. What's the opposite of squaring? Square rooting. T is equal to the square root of 30. And that is approximately 5.47. That would be approximately 5.5 seconds. Any questions? After about 5.5 seconds, the object is on the ground. Okay. Look at the problem again. We set it equal to 0 and we solved. We knew that we would not get a whole number, and that is fine. The profit made by a small business on manufacture and sale of X items is modeled by the equation. P of X is equal to the opposite of X squared plus 126X minus 1100. So what is the value of P of 0? When I put 0 in, what happens? Okay, 0 plus 0 minus 1100. So when I put 0 in, it is equal to negative 1100. Negative 1100. What does it mean? Okay, X is the number of items. How many items have we sold? We haven't sold any items. What does it cost us to get those? $1,100. So the cost of X items is $1,100. So when we get ready to sell, we're going to have that $1,100 to buy our product. Algebraically, find the number of items that should be manufactured and sold in order to realize the maximum profit. Now, remember, we're looking at the upside-down parabola. The maximum will be the vertex. To find the vertex, it's the opposite of b divided by 2a. This is in the form of ax squared plus bx plus c. What is my a? What is my b? A will be equal to, if I had to put a number there, it would be -1. B is equal to 126. Using our formula, the opposite of 126 divided by 2 times -1. Negative 126 divided by -2 is positive 63. So when our x value is at 63, we will hit the maximum of our quadrilateral. So, what is the maximum profit? We're going to use that same equation and put in 63 for x. So we're looking at our P of 63 is equal to the opposite of 63 squared plus 126 times 63 minus 1100. The opposite of 63 squared plus 126 times 63 minus 1,100, and what do I get? 2,869. What's the maximum profit? The maximum profit is $2,869. So what you're looking at, you're looking for the x value at the vertex. To find that x value, it is the opposite of b divided by 2a. If you think about it, that is kind of like the the quadratic formula. A baseball throwing machine is being used to help players catch pop flies. The machine shoots the balls into the air. The height of the ball after t seconds is found by the function h evaluated with t is equal to the opposite of 16 t squared plus 48t plus 4. So the first thing we're going to do is find the x value of the vertex. So the opposite of b, the opposite of 48, divided by 2 times negative 16. So I'm using parentheses. I'm going to do it all at once in my calculator, and I get 1.5. Okay, so I want to think about this. What happens if I graph? What happens if I graph my equation? I put the equation in there. I'm going to hit graph. If you notice, I've changed my window so I can see it. If I hit second and trace, I want a maximum, so I go down to 5. Left bound means the left side. I'm on the first side, so I hit enter. I use my scrolling arrows here. I go over the top. I hit enter again. I hit enter a third time. It is not working, so I'm going to start back over. Second, trace, 5. Oops. It should be 4. 4 is my intersection. So go over here, left bound, left side, enter. Right bound, right side, enter. Got a guess. I don't care about that guess. Enter again. I've got the point 1.499, 1.5, 40. How high does it go? Well, now we know it's 40. To do it algebraically, we're taking our h and we're going to put 1.5 in for x. We get negative 16 times 1.5 quantity squared plus 48 times 1.5 plus 4. negative 16 times 1.5 squared plus 48 times 1.5 plus 4, and I get 40 again. So if you're looking at this, either way you're going to get the same thing. You can always graph and hit that second and trace and come up to the intersection, or you can do it with algebraically. So my total at 1.5 seconds, my height will be 40 feet. The maximum height is 40 feet after 1.5 minutes. So this is how you apply your quadratics, how you use a quadratic to find minimums and maximums. You start with the idea of the x value of your vertex, the opposite of b over 2a. You can kind of remember that from the quadratic formula. So how do you know you're successful? When you can use quadratics to solve problems. So remember your vertex when you're looking for the x value, you're going to take the opposite of b over 2a. Use as x to find y, to find the output. Hopefully you understood what was going on. Once you get used to it, it's not a horribly difficult concept.